Hey guys, it's Mr. Hall again. Today I want to talk to you about making groups of 10. On the surface, this may seem like something that is maybe for first and second graders, but if we can master the idea and get used to the idea of making groups of 10, all math will become much easier for us. This particular lesson will be fairly short, and I'll do a couple other videos talking about how we can actually use those groups of 10. But of course, we all know, we all understand the number 10. It's just one of the numbers of many numbers that we work with every day. But 10s are very special because our number system is what's called a base 10 system. Because we only have the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Not a new concept for us in the 5th grade, but I really want to concentrate and think about the fact that all numbers, any number that you can create, is made from these 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Every other number that we make is made from those digits. Now let's talk about some groupings of 10. I just want to keep in mind that I'm going to start just very basic. If I have nothing, if I have 0, and I am attempting to make a group of 10, I'm going to have to add or combine my 0 with 10 to make 10, which is where the simple addition problem 0 plus 10 equals 10, that's where that comes from. So now, if I start with $1, $1, 1 Coke, 1 whatever our object may be, and my goal is to make a group of 10, I will have to combine that with 9 other objects before I will get my 10. And I'll talk about the pattern that arises as I continue to make these groups of 10, but let's get at least one more down before we start talking about patterns. Next up would be the number 2. And if I had 2, I will have to combine my 2 with another 8 to make a group of 10. Actually, I want to do one more before we start talking about our pattern. So, if I'm starting with 3, if I have $3 and I'm wanting to know how many more dollars I need before I could trade that in for a $10 bill, I would need to have 7 more dollars before I could trade it in. Now I think I have enough to start talking about the pattern that emerges. If we look at the left side of our equation, I like to talk to you all about how these are equations. This is the right side of my equation. This is the left side of my equation. Now if I'm looking at just the left side here, I see that my first digit starts at 0. My next problem, my next group of 10 that I was making, I went from 0 to 1 to 2 to 3. And my second digit in my equation, with my 0, I had to add a 10 to make my 10. With my 1, I had to add a 9 to make my 10. With my 2, I had to add an 8 to make my group of 10. So, as my left digit increases by 1 with each new problem, my right digit on this side of my equation decreases by 1. So I go from 0 to 1 to 2, 3. And here I start at 10, 9, 8, and 7. And eventually what's going to happen is we're going to meet in the middle. So if I have $4, I need 6 more to make a group of 10. And finally, if I have $5, I will need another $5, and I have my group of 10. Now I could continue going, but what ends up happening, if we pay attention, is Now that I have met in the middle, let's outline that in green real quick so it shows up. Now that I have met in the middle, and we like to call these doubles. These are one of our doubles. I may do a quick video on those coming up. But once I get to my double, 5 plus 5, I start working backwards. And as we can see, I get to 5, and my numbers still continue to increase here, 1, 2, 3, 4, 5, 6, and 7. But what I have, if we pay attention to these two problems right here, I see that 6 plus 4, and if I come back up here, is basically the same. It's not the same, but it is the same as 4 plus 6. I have the same two digits, but if we think about it, if we thought about that in counting objects, if I start with 4 green dots here, I would need to add or combine them with another 6 green dots before I have enough to make my group of 10. Now down below, while I'm adding the same two digits, yes, I'm starting at 6 dots, and I'm adding that additional 4 dots, and I still end up with the same group of 10. That's important because when we add numbers, it's nice that if I saw a problem that was 2 plus 47, it's much easier to think about the problem 2 plus 47 because we're allowed to flip-flop our numbers. That's what's known as the commutative property of addition. For me, it's much easier, even though I can get this answer of 49, it's much easier for me, anyways, to start at 47, start with your larger number, and then add that smaller number. That's much easier for me to process, although I end up with the same answer. So that's a nice characteristic of addition. But let's go back and focus on these groups of 10. Guys, if you can remember these, and keep them in your head, almost think of these as the same thing as you think of multiplication facts. They're just something that you need to know. If we can keep these in our head, when we start doing larger addition and subtraction problems, when we start doing multi-digit multiplication problems where we have to stop every now and then and add some regroupings, or we have to add partial products, and when we get into division, when we have to subtract, if we can keep in our heads how groups of 10 are formed, addition and subtraction will become much easier because you'll learn to recognize that if I have 2, I will need 8 to make a 10. If I have 4, I will need 6 more to make a 10. And in future videos, I'll show you exactly how we can use this. Thanks for watching, guys.